Hello and welcome to Selenium for Beginners. We are going to discuss how to create our own customized XPath values. The cheat sheet, transcript, and presentation will be available on GitHub at rexjones2/Selenium for Beginners and tinyurl.com/Selenium locators for web elements. We will look at the difference between absolute and relative XPath values, XPath functions, and XPath Axes. We are going to use 4 different applications to walk through all of these XPath scenarios. What is XPath? XPath is used to navigate through elements and attributes. XPath is short for XML path, and XML stands for Extensible Markup Language. XML is different from HTML. XML is used to carry data, and HTML is used to display data. With regards to Selenium, XPath is a locator used to extract or pull tag attributes. There are 2 types of XPath, absolute and relative. Here's the syntax for an absolute XPath. The absolute XPath always begins with the root element, which is HTML. It can start with a / before HTML or without a / before HTML. However, a / will always come after HTML, followed by head or body as the next element, and stop with the last element. Relative XPath always start with 2 /, which selects a direct tag name, followed by a condition. The condition is located inside 2 square brackets using an @ symbol, attribute equal to the value, surrounded by single quotes. Our first application is Demo Web Shop. Let's inspect the search button. As automation engineers, we should not copy the XPath values from Chrome Dev Tools. That's when we right-click, select Copy, Copy XPath. Control F, then paste the value, and we see an absolute XPath value. Sometimes Chrome Dev Tools generates a relative XPath value. I will admit, I have used Chrome Dev Tools to copy XPath, but that's because I had not created a video showing how to customize our own XPath values. Let's break down this absolute XPath. It starts with /HTML. Then we see body. A / provides access to the next element, which is a child element. Within body, we see 4 div tags, 1, 2, 3, 4. The XPath shows div 4, which means the 4th div tag. Maximize div 4, and we see 2 div tags. The XPath shows div 1. Maximize div 1. Now we see 4 div tags. The XPath shows div 1 again, and we see 4 more div tags. But this time we need the 3rd div tag because XPath shows div 3. Maximize div 3, and we see the form tag. And finally, the input tag. And XPath shows input 2, 1, 2. And we see all of the attributes for the search button. That's a lot of navigation to find one element. It's not a good practice to write an absolute XPath. If anything changed between HTML and input 2, such as div 1 changing to div 2, then Selenium will no longer find the search button. That's one of the reasons why we should not use absolute XPath. I recommend we use relative XPath. Here's the cheat sheet for relative XPath. I created it as a reference for you to download. First syntax for the search button, we write 2 forward slashes and the tag name input. There are 15 web elements with inputs as their tag name. We can write any tag name and see how many elements contain that tag name. The search button is 2 of 15 for input tag. Continue with an opening and closing square bracket. @ symbol, then attribute name. The attribute's name can be any attributes within this element. Type, class, or value. Let's write type. Followed by an equal sign. After the equal sign, then write 2 single quotes. And the attribute value submit. We see the element shows a green highlighted background, which means success. If we hover over the element, then the web element is highlighted in the application. That's the difference between absolute and relative XPath. The next syntax is an illustration of 2 or more attributes, names, and values. This syntax operates like the logical AND operator using 2 or more conditions. Let's inspect the excellent radio button. According to the Selenium locator rankings, we would use ID or name before using XPath. However, here's the power of XPath. Let's imagine the application is under construction and the architect wants to make sure these attribute values do not change. We find the element by using multiple attributes, and if it breaks, we know one or both values change. 2 forward slashes, tag name input, square brackets, @ symbol, attribute name ID, equal, 2 single quotes, then the attribute value polled answers -1. We found the element, but let's add the square brackets again, @ name equal 2 single quotes, then polled answers -1. Success. The next syntax is the AND operator. It's our preference. We can use the AND operator or multiple sets of brackets. Go back to the AUT. All we do is replace the inside brackets with AND. We still have our element with 1 of 1. Both syntaxes operate the same. The next syntax is the OR operator. change and to or. But now we have one of four. Search, search, search. Why is that? That's because all four radio buttons have the same value for name. Poll answers -1. Let's inspect search store. This is a different scenario. Imagine the architect is okay with one of the attribute values changing, but we still want to find this element. We replace ID with small hyphen search terms and the name with Q. Now we see one of one. There are times when we have to use indexes to find our element. The next syntax has an index for tag and name. We are going to switch AUTs and look at tables using W3 schools. Inspect Helen Bennett. It's best to write this XPath by starting with an attribute within the table tag. Table is the parent element for tBody, tAura, and tD. tBody describes the table body. tAura is table row, and tD is data in a particular cell. 2 forward slashes, tag name table, square brackets, at attributes name ID equal 2 single quotes. Then the attribute's value is customers. 1 forward slash after the bracket, which provides access to the child element tBody. Which row is Helen Bennett? 1, 2, 3, 4, 5. We write / tAura bracket 5. Helen Bennett is the second cell, 1, 2. Therefore, we write / after the bracket TD brackets 2. The green background indicates we have found Helen Bennett. You can find this cheat sheet at tinyurl.com, Selenium locators for web elements, and GitHub at Rex Jones II / Selenium for beginners. Next is XPath Functions. The next AUT is GitHub. Let's inspect the notes below username. Here is a special case where XPath or CSS selector is our only option, and a perfect example to show you why we should not use Chrome Dev Tools to copy XPath. Copying an XPath value works sometimes, but it is not reliable. Therefore, it is best not to right-click, copy XPath, then paste XPath. Notice the ID value. Now I am going to reload the page. Copy XPath again, then paste XPath. Do you see how the value changed after reloading the page? That is called a dynamic ID value, where the value changes every time. This video will show you how to handle dynamic values using XPath functions. There are 4 types of XPath functions. On Oracle sites, we see node set, string, Boolean, and a number. Our focus will be the string function. In our cheat sheet, I call them partial pattern match because all we need to do is match part of the attribute's value. I was going to demo 3 functions, but I will remove ends with, then demo starts with, and contains. Back to our AUT for the starts with function. We write 2 forward slashes. Tag name is P. Opening and closing brackets, starts with. Opening and closing parentheses. @ symbol, the attribute name is ID, comma, 2 single quotes. Then write what the value starts with. The value starts with description. So let's write description. We can also replace starts with and use the next function contains. Both functions will work because the value starts with description and also contains description. Go back to AUT, remove starts with, then add contains. Did you notice that we have found 1 of 2? 1 of 2 is not good enough if we are looking to only verify the notes below username. Both elements almost look the same. How do we find 1 of 1 when both elements have P as the tag name, class attribute with the value of notes, and a dynamic ID value? One note refers to the username and the other note refers to email address. We can use a word or we can use a phrase from the note. Inside the brackets, we write and contains. 2 parentheses, we write dot, comma, 2 single quotes. Within the quotes, we can write the complete phrase or we can write the word. The phrase can be, "This will be your username." Now we have 1 of 1. However, I prefer to use a unique word like username. And we still have 1 of 1. This query is asking us to find a P tag and ID attribute consisting of a description value and contains text username. We can also replace the dot with the text function. However, there are cases where text will not work. I will create a video explaining the difference between using an XPath value using a dot and using text. TEXT 2 parentheses. We still see 1 of 1. If you choose not to write the word and, you can replace it with the square brackets. Let's go to Tools QA and continue with a different syntax for the text function. Inspect first name. We see a strong tag name, but don't see any attributes. Write 2 forward slashes, strong, both brackets, text, 2 parentheses, equal, 2 single quotes, first name, colon, and bingo, we found our element. That's it for XPath Functions. You can download the cheat sheet and the transcript from GitHub at rexjones2/Selenium for beginners and tinyurl.com / Selenium locators for web elements. Next is XPath Axes. Next is XPath Axes. An axis represents a relationship. That relationship depends on the current node, and it is used to find other nodes like a parent node, sibling node, or child node. There is a total of 13 XPath axes. In alphabetical order, the XPath axes are number 1, ancestor. Number 2, ancestor or self. Number 3, attribute. Number 4, child. Number 5, descendant. Number 6, descendant or self. Number 7, following. Number 8, following sibling. Number 9, namespace. Number 10, parent. Number 11, preceding. Number 12, preceding sibling. And number 13, self. Here is the syntax for an XPath axis. Axis specifies the tree relationship between current node and selected nodes. The two colons separate an axis and node. The node identifies the tag name, and index is not required. It specifies the node sequence. We are going to cover the following and preceding XPath axes. The preceding axis select all tag names before the current node, and following selects all the tag names after the current node. Let's pick up where we left off after using XPath functions. Right now, we have already found the first name label. To use the preceding XPath axes, we write 2 /. Next is the preceding axis. 2 colons, then the tag name. The tag name depends on the elements we are looking for. How about the link element, which has an A for anchor as the tag? This query returned 177. The index is optional, but let's narrow our search down to link text by writing 1. 1 represents the first anchor that precedes the first name label. To select partial link text, we write 2 because it is 2 elements before the first name label. The next axis is following. Let's select all of the input tags after years of experience. Inspect years of experience. We see a label tag name. Let's write 2 / label, brackets, @. There are 2 attributes, class and for. If we use class equal control label, then the query returns 3 elements. 1, 2, 3. Years of experience, profession, profile picture. Therefore, let's use the for attribute. FOR, EXP. Now we see 1 of 1 for years of experience. Then write 2 /, following, 2 colons, input. There are 20 input elements following years of experience. Search, 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 search. Some of the elements are the radio buttons for years of experience, date picker, manual tester, automation tester. That's how we select web elements using XPath Axes. You can download the cheat sheet and transcript at tinyurl.com, Selenium locators for web elements, and from GitHub at rexjones2 /Selenium for beginners. Hello and welcome to Selenium for Beginners. This video is a spin-off from the XPath Function video number 44. In that video, we looked at dynamic values. The XPath text function and dot located a value that changed in the DOM. However, I mentioned there is a difference between the text function and dot. We are going to look at the difference between both XPath concepts using this presentation, then demo Google. In this example, we want to find success. First, we locate class search results, then try to locate success. Notice success is between the EM tags. EM stands for emphasis, which boldface words on a web page. In order to find success, we would not use the text function, but use the dot. The text function will not find success because the text function locates content in a text node. A text node only contains a string, and the strings are located inside quotes. Therefore, the price of and is hard work, commitment, and dedication are text nodes. As a result, in example 2, the text function will locate success. We see success is located in the text node. The third example is kind of tricky. Success is located inside a text node, but it does not have a direct relationship to the element. What is the element? The element is div class equals search results. Therefore, the text function will not find success in the second text node. On the other hand, the dot for XPath will find success in all 3 examples. Now, let's go to Chrome for our demo. Search for Selenium automation and inspect the description. We see tag name is span and class is st. Write 2 forward slashes, span, 2 brackets, contains, parenthesis, at, class, comma, 2 single quotes, st. Let's try out a few things to see the difference between dot and text. Starting with dot, I am going to write 2 brackets, contains, 2 parentheses, dot, comma, 2 single quotes, and search for Selenium. There are 6 results. Search all 6. Selenium, 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 and Selenium. In each one of these results, Selenium is located within the EM tag. The web page shows Selenium boldface. Change the dot to text. And as expected, the text function returns no results. Change Selenium to test. And there are two results. Test, search, test. Test is part of testing, and it is located in the first text node directly related to the element with the span tag and class containing st. Change the text function to dot, and we see three results. The text function did not find test for this search because it is located in the 1, 2, 3 third text node for HP, Quick Test Pro. That's it for the difference between XPath text function and dot.
All Part 1 ebooks and PDF documents are free. Programming books for UFT. Programming books for Java. Here's the Selenium automation book. And TestNG. Subscribe to get notification of future videos. Don't forget to like, comment, and share.